like that.
A couple quick things about safety here. The site's raw. So this was left in 78, pretty much just like this. They have done some demolition, and we'll get into that whole story. So there's yellow chain. Don't go past the yellow chain because I can't guarantee you I'll ever see you again. Literally, there's pits full of water. I don't know where some of these pits go, so be cautious. There's holes that if you fall in, I probably won't see you again. And that's okay, because you weren't here. Your safety thing is ripped up. You guys were not here. I tell everyone, you're fired before you fall, and this is the same thing. All right, so just be cautious of that. On the grounds here, you don't have to worry about your hard hat. When we go inside the plant, wear your hard hat, please. There is things above our head that we could hit, we can bump, that's what they're for. The other thing that happens here occasionally is rust and spall has a way of falling here, and it's usually when there's a tour. So it's like, oh shit, I'm trying to sweep it under the rug. But that does happen here. So the idea of steel making it's been the same. This has not changed. I like to say people have been doing this since and before that they wore really pants, because it is. It's the same process. You take a couple things out of the earth and you get them really, really, really hot. So you have iron ore, which is here, and we have art on iron ore, which is, ooh, don't get me started. Later on in life, we turned it into taconite. So here we have iron ore, which takes quite a bit to melt, but we can make taconite balls, which this is 70% efficient iron, and this is going to melt way quicker. So we can make it very efficient.
Has anybody ever seen on the railroad, certain railroad tracks, you can see that stuff spilled all over
everywhere.
the place. All over the place.
Yep. Great in slingshots.
We used to use it that way.
I don't. Okay. All right. I'm not gonna tell you how I know, but this is what this. Oh man, we used to look for this as kids.
That's what I did too.
Yeah, because your wrist rocket.
Does that melt quicker because it's smaller, or because of the composition?
It's a composition, so it is smaller, so it's easier to melt, but it's also 70% efficient. I don't have a bunch of extra
stuff,
whatever's in it, So they did taconite. So taconite, iron ore. And you take coke, not the good kind. Take coke, which this is anthracite coal that they have baked in a oxygen depleted environment. So we get all the crap out of coal, which if you guys have ever smelled coal burning, there's a lot of volatile things in coal that is absolutely nasty. And you end up with basically a chunk of pure carbon. This chunk of pure carbon, when heated up, burns very, very, very hot, and it stays nice and hot to the point where we can actually, without even air putting into it, and we'll get into that, it will melt iron. So Clairton Works, the sore spot of U.S. Steel right now is Clairton Works. This is what they make a lot of. The problem with coking is it's the emissions, which we hear about all the time. We hear mostly about the emissions, the air quality alerts. That's actually not the bad stuff on coke. The real bad stuff on coke is the volatiles that come out, which are benzenes, light oils, heavy liquors, light liquors, this stuff is not good. So when you're in a coke plant, you smell like a magic marker all the time because it has the strong sense of benzene in it. This also will have heavy oils, tars, and light liquors, which are really not good either. That stuff is, I've worked in coke plants, and then anytime someone says byproducts, no thank you. All right, so that's the byproducts of making this, which is, it's good, but not good. And then we have, which we don't have here, we have some pieces, limestone. This is pure limestone. Use it as flux. So we're going to flux off all of our slag in the furnace you put limestone in. That's the three processes of making iron. When you have it up to a certain temperature, so the other thing that you'll see in this is lots of brick. Man, these guys were great brick masons. I wish I could hire about 7 of them. All right, so there's a lot of brick, all fire brick. So we have 2 types of fire brick. Standard, what you're gonna see, we call standard fire brick in the mills. And you have something that looks like this. It's darker. It's got a lot more graphites in it. And this would be in the blast furnace. So they would use this as the first shell of your lining. So there's, in the blast furnaces and the stoves, just packed full of brick. And some of the intricacy of it is how do you get brick in a circle, and that's why they have them cut like a triangle. So these are they're very important. The other important thing that we have in Pennsylvania on Three Rivers, a lot of water. So everything here takes a tremendous amount of water to cool it. These blast furnaces are unique, and when we go in there and see it, you'll see it. They are not water cooled to the very top. So we are water cooled from the hearth to about the melt zone. Past that, they're air cooled. All of our modern furnaces now are water cooled from the bottom to the top. So these, I'm going to be a little biased here, are the 2 best blast furnaces in the world that are saved. So why that is they're the oldest, they're pre-war, they're only water cooled from a certain part. Our cast houses are the best. And I've been to Germany, I've been to France, been to Luxembourg, I've been to all these World Heritage Zones that have furnaces, and they're all newer. There are 50s and 60s, some are 40s, so they are more technologically advanced, but they're not as cool to look at. So, way to go, bro. There is another set of blast furnaces in the United States. It's called Sloss. So Sloss has a very similar setup to what we do here. They're just smaller to the point where we could put one of theirs in ours. And ours aren't big blast furnaces. So out of the 7 furnaces that were at Carrie during the time, this is 6 and 7. 1 through 5 are over here, and 3 and 4 were going to be the biggest furnaces, and that's all gone. So 78, we shut down here. By 86, 87, they had a company named Park. So Park Corporation bought all of Homestead Works. They bought a lot of J&L. They were resellers. So they did the demolition, they took all the equipment out and they resold it. We know that some of this stuff is actually sold to China because there's rolling mills over there that have Mesta written on it and Mesta machines from right over here. We're pretty sure that were the ones from Homestead Works. That was business apart. The problem is during this time, when you lay off everybody in Pittsburgh pretty much, and you are tearing down their livelihood, you're going to have some issues. Some of the issues with Park were death threats, damaging of equipment. So Park did something very interesting in Pennsylvania. They changed their name, and they changed their name to Wemco. So Wemco across the river is West Homestead Engineering and Manufacturing Company. It's actually a Park-owned corporation, but because of the bad blood that Park has around here, and they're actually very nice people, they changed their name to Wemco. Park owned this, and a company, a conglomerate of people called Industrial Heritage Corporation tried to save it. So that's the early version of Rivers of Steel. It was literally a grassroots of 5 or 6 people that came in here and said, we need to save this. How are we going to do it? We have no money. How are we going to do this? So there was a lot of conversations between Rivers of Steel, Park Corporation, and Allegheny County. So Allegheny County actually helped save it. When we walk around to number 7 cast house, you're going to see what Park did to us when they said, you might not be able to save us. And we get to see something in the blowing engine house. Technically not allowed in the blowing engine house, but you're with me, we can do whatever we want. So what we're going to do is we're going to go through the process of how it came in. So we're going to go from the start and we'll finish. That's what it's here for, to get them happy.
Imagine this thing full of
This
metal.
right here
yeah.
is an early way to get hot metal across the hot metal bridge, and this is what they call a cling car. So this is an open top car that would have hot metal in it and go across the bridge. Pretty cool, pretty efficient. You can lift it off with the ladle hooks on the crane really easily. You can dump it. There's one thing that might be slightly a problem with the cling cars is they're open top and we're going over water, even though we have the best bridge in the world. If we spill hot iron anywhere around here and there's a puddle, man, that guy had a bad day because it explodes instantaneously. So, older style. And
I
then,
have a dumb question.
no dumb question. Go ahead.
You'll be surprised with the answer. If this was full of hot metal, what was keeping this from melting? Like, what is this made out of so that the inside's not also really
Just luck. No. So what they had in here.
I've always wondered that.
Yeah, okay, so here's the refractory brick that we looked at.
Yeah.
This is what this is lined in.
Oh.
So we have and this doesn't always work. We have a really thick shell. The shell's about an inch and a half thick, 2 inches in other spots.
Of steel or of metal?
Of steel, yeah. And then we have a refractory brick lining in here. So they would brick it, and on top of that they would put a very, I say thin, but maybe an inch and a half coating of refractory on top of that, and that's what would prevent it from melting. Now, it would melt occasionally, and you'd have to reline it, but that's why it wouldn't just pop through.
That also sounds like a bad day. Like,
That's what Heather, you're gonna reline that?
It's a bad day. Yeah, it's a bad breakouts. So that's what when you hear steel workers, anybody in a mill, they talk about, oh man, we had a breakout. That's what happens. We have hot metal in a vessel that broke and burnt through the vessel and is now spilling all over the place. You can't stop it. You can't control it. You just have to kind of get away from it. So what they do, and what you can do, is you put it on a crane and just run it up and down an aisle and just let it spill out all over the floor. Then you come in with big heavy equipment and you push the still molten iron or steel out of the way. So it depends on what happens. U.S. Steel did this not too long ago, I think 4 or 5 years ago. This happened with a ladle that they were transporting. It broke out and caught the asphalt on fire in the driveway. And they had a huge fire down there and it was just the asphalt melting and you can't do anything with it. Just let it hang out. So, I mean, it does happen. Thank God for OSHA. That's all I have to say right now. I've worked in the steel industry for a very long time, since I was 18, unfortunately, with my family, and it's just one of those things. OSHA helps, but everybody industry here? Everybody's industry, okay. Production wins. So safety's there until you need to hurry up and get it done. The beginnings of how to make iron, especially here. So this is actually probably about 10 to 15 feet higher than it should be right now, the ground level here. What we would have between the ore yard wall and the stocking trestle would be taconite, and it would be filled up to pretty much the top of that railing on this at all times. We kept, about a year and a half's worth of taconite here all the time. You run out of taconite, you can't make any. The problem with this is we get iron ore from Minnesota, and we get it via the Great Lakes from Cleveland, and then rail it down here. Great Lakes have this great thing, they freeze. Not all the time, but they do. And when they freeze, we can't have iron ore tracking. So this is always filled up. It came here via a railroad, and we brought it into the car dumper. Now, I'll say it again, this is the best car dumper in the world. Actually, it's probably the oldest. So this is not a rotating car dumper. We'll go up on it and you'll see there's an actual mechanism. We would pull a railroad car on here, we would lift it up, we would dump it, set it back down on the ground and pump it out. So, the whole car. Yep, the whole car. So this is some of the innovation that has happened in the steel industry that Carnegie was really good at. It was good with automation. much as you can be in this time. Here we have an ore bridge, we have skip cars, and we have hard iron. We'll explain why this is important, because before we had this, it was hand loaded. So they would have a tremendous amount of people here literally loading our products into the top of the furnace by hand. You'll hear that they had mules helping, and they did. They had some animals, and that's very, very early on. And how to make it more efficient is mechanizing, automation. So this still took a tremendous amount of people to work here. We're talking thousands of people, all the time, every day here. But this helped lower the amount of people that were needed.
Did the mill operate 24 hours?
24 hours, 7 days a week, no days off. That's the last thing. In a mill, you don't want a day off because it's
We
bad.
just start everything out.
Yeah. Some of the issues with blast furnaces. They're pretty dirty. They make wonderful steel and iron. The product that comes out of this is very enriched. But you can't shut them off. Once you start them, you got to keep going. There's a tremendous amount of labor and a tremendous amount of money that goes into rebuilding these when they already got lifespan. Your lifespan of a furnace could be 10, 20, maybe 5 years, depending on how hard you run it and who is running it and what you're running. So, antiquated, really.
So did you always have all of them running, or did you kind of have one down so you could always flop and still run at full capacity?
All the time. Run it all the time.
All 6?
All the time.
All seven
sorry.
would be here, would run all the time, unless these two had an outage, then they would only be down for a very small period of time, because you want to make them produce. If they're not producing, they're not making money. So the tonnage is what you want out of here. So how much iron you push out is how much money you're going to make. So a lot of people in management, even to this day on steel industry, you get bonuses by how much tonnage that you push out. So it's really all tonnage, and that's what they care about the most. So the easiest way to do that is don't have breakdowns, don't have lots of call-offs or slowdowns, so you just push the furnace. And you'll know when certain furnaces go down. Edgar Thompson did this not too long ago. You'll know when you can tell that they're going to go down for a while, because that furnace will run very hard, and they'll produce as much as they can so they can just bank it and let it sit. So when they're on an outage, they still have product to sell. Steel is really interesting because it's run by accountants more than it's run by anything else now, because you get taxed on everything that's sitting. So how do you make that? That's above and beyond me. I was like, just tell me what to fix and we'll figure it out. I don't need to know. I don't want to, So, but yeah, so we have the ore yard here, and literally years worth of iron ore all the time, taconite, and it's still, if you look at some of the corners here, there's still iron and iron ore stuck, and we can't get it down. It's literally trees growing out of it, which happens still. That's some of the, if anybody's good with the lawnmower, let me know, because wow, that's one of the biggest things that we have to deal with here.
How did they actually make the taconite? So if it came in like ore in the big chunks.
Yeah, they didn't make the taconite here. They would mine the iron ore out in Minnesota, and they put it in basically a big trommel mill. So they would just rotate it with heat, and eventually you would just have your actual iron out of it.
So that was the little pellets where it would actually end up
That's what
coming here
ends up.
eventually.
Yep.
Is that sort of tumbling rocks? You have people
Very
that,
close,
tumble?
with more heat and more pressure.
Yeah.
Very close.
I know, right?
Glad you brought that up.
I have a, what's the source of power before low tone double power all the time?
Well, the thing here is they did all the mills. So that was one of our big things. We didn't have power up until about 3 years ago. Well, I guess it's been 5, 6 years. But we never had power on the site, because when the mill shut down and they tore everything down, there's nothing. There's nothing here. No water. Well, there is sewers, but they go to the river. And then, no running water, no electricity. They generated everything by themselves. So the AC powerhouse here was what was generating all your AC and DC power.
What was the generator? Water.
Steam. Yeah. The steam engines. Yeah, from steam engines they went into different kinds of generators. They had a central generating plant down here later on in life. We also had a central blowing engine house basically for all the furnaces later on in life. And these two buildings turned into storage for the AC powerhouse and a maintenance shop for the blowing engine house. So we still use it as a maintenance shop to this day. That's where all of my equipment and tools are, and we have a very large rolling mill right in the middle of the room too, which when we go in there I'll tell you.
So when you say a maintenance for this facility?
This facility. Yeah, we try to do a lot of the maintenance ourselves, and sometimes it's cutting grass.
Yeah.
And then we use the ore bridge to dump it. So the ore bridge over here is a very large crane that you see. This is 1958 was the ore bridge is a rebuild here. Before one large ore bridge, there was two smaller ore bridges that went back and forth. They found out that one large ore bridge was more efficient to move the taconite over the site. So now we can do it.
Those counterweights?
Yes, those are all counterweights. Yeah. Those are all counterweights. Unfortunately, braided cable. So this is all old style. Yeah, this is all old style braided cable that they've done. There's been some updates and some repairs with Crosby clamps to help.
Did they make the weights here?
Now this, I don't remember right now where this came from. This was bought from a company, and I want to say there have only been 3 or 4 companies that sold it. I'm not sure which one it was.
I like
literally collapsed about a couple years ago to the point where they look like S's. So all the weight that was holding above it pushed down, and the I-beam literally looked like that. And it was a big problem because it's holding a tremendous amount of weight above it, to the point where we had to measure things. I mean, you go right to kips. There's no more tonnage. You know, it's just right in the kips. So we came up with some interesting ideas of how to hold all this weight and be able to drop the bottom of the weight out. And one of the things that we did is we made a false work. So we took iron, put them on top of the stocking trestle. Inspection process, we actually shoot it with transits, lasers, drone scans. I can see how much everything moves. And things will move tremendously, and as it moves, we have the ability to see what I need to start fixing. And without a print, that's what we needed to do. So we had to actually start and re-engineer the whole place. But it's great because I can literally see my connections. And we did it last year and 2 years. So I actually have, excuse me.